Ajay Sood. Um, there could not be anybody better than him to give this public lecture on the 90th Foundation Day of INSA. And so all of us know, of course, not all of us know, I see some younger friends there, that Professor Sood was earlier also the president of INSA. And of course, there have been great strides uh, in INSA during his tenure, as indeed the tenure of all other presidents except me. And so when I look at all these names of previous presidents of INSA, they're all textbook material. I mean, all of them are actually. So it's fantastic. So it is great that we have INSA that was led by none other than Professor Sood. And then, of course, he's been a great scientist. I know his science for nearly, yeah, maybe 35 years or so. And so, we even before the lip service to interdisciplinary science became so prevalent, he was the original interdisciplinary scientist. And so I was a chemical engineer, but he trusted me to do some science. And so that's clearly not many people would actually do that. And in fact, if I were to recall my first project, it was an Indo-French project, he was a referee for it, and it got great reviews. I got that project, and I was collaborating with a physicist in France. So truly interdisciplinary, if you would. So now, of course, interdisciplinary word becomes very important, and everybody says it. At least I mean, every director of every IIT, everywhere, they talk about interdisciplinary. Of course, they can't really enforce it too much because hiring, firing is done by departments, and so being interdisciplinary is very hard. But so we all know him. That he was a great nanotechnologist. He led the nano mission in a very essential way for a very long time. And now being the principal scientific advisor to the government of India, he has both a very wide footprint and very long hands. That's an interesting metaphor. And so that he can actually impact the policies directly, the way government looks at science, engineering, technology, medicine, so on, and its applications for societal benefits, and its impact on economy and everything. So that he and his office are making many of those things possible. As a physicist, clearly, as a physicist of great excellence, and of course that is a fellow of Royal Society. There are not too many fellows of Royal Society in India, and he's been at a rather early age and has contributed. So by the time by the way, we had recently, INSA delegation had gone to Royal Society, and we found a lot of archives related to Indian science and scientists there, including the first president of INSA, who was then a British FRS living in India. And that's how INSA came into existence. So it's a great tradition. And I was saying in the morning, look, now it's the 90th year of INSA. Great minds have contributed to it. But it takes a bit of time for academies like this to stabilize and to make a huge impact. Royal Society is 365 years old. So while 90 years is a good time to look at the foundation and start building on it. And indeed, a lot of that is being built now. But anyway, I was going to welcome. This is a welcome address. So I first of all welcome everybody who has taken time to come out here. In addition to the chief guest, Professor Sood, that there are also vice presidents of INSA here. There are many fellows of INSA. There are senior fellows of INSA, those who became fellows before 2005, who were actually honored, felicitated today. And we were so happy to have them in our middle, that inspiring us, with their life and works. And so it was a great experience for everybody. And I see that there is a full house here, so I would not really stand between you and the great lecture that we are going to hear now, which is a very interesting lecture theme, My Journey from Vigyan to Vigyan Bhawan. Now, all those of you who don't know what Vigyan Bhawan is, this is the office of Principal Secretary, Principal Scientific Advisor to the Government of India, which is where Professor Sood sits. So it is both metaphorical, it's symbolic, being a great scientist and then being a great policy maker and administrator. And how does that journey mesh into each other? How does one part of it inspires the other, if you would? Because doing good, great things today is only about connecting different domains of knowledge and expertise which have not been connected before. So a good scientist brings a lot to an office like that. An office like that also brings great things to science. And so both of them working together seamlessly, that remains the dream of doing true science, doing effective science, and bringing the concerns of science in India to the forefront. So I thank everybody, I welcome everybody from being here, and then let us buckle up, wake up, and listen to the lecture which is going to unfold right now. Thank you very much.
Yes. Yeah. Thank you very much, Ashutosh, for many things. Thanks first for inviting me at the last minute so that it doesn't give me much time to really put together whatever I wanted to say. So the blame of not giving a good talk rests on Ashutosh. That's the first message. Second, Ashutosh is also settling scores. Why? Because when I was president, I invited him as a DST secretary to grace the occasion for some award function, and that entitles him to invite me, and now I'm reciprocating. So one is to one. And third one, the third reason is I'm truly excited to be amongst you on the 90th birthday. I think this institute has been a pillar for a long time for anchoring the science policies, though not saying policies, but affecting it without saying it, in terms of charting the course, in terms of interacting with the international organizations like ICSU, now it's called ISU, and connecting to different academies in the world. So this is really a gateway for connecting Indian science to global science. So it's a great pleasure. And when Ashutosh asked me, I gave this title, which is a slightly different version of a talk I had given, but with different content, where I thought people always ask me, as if I am a born bureaucrat, which in Delhi it's difficult to dispel. But then one has to keep in mind that we come from science domain, and science is of paramount importance in logical thinking, and that logical thinking leads to the right policies. So there is no big mystery here that how we can seamlessly go from doing basic science, fundamental science, applied science to the policy domain, because policy, I will just show you, without that it will be bit just putting a overlayer, not really going into the depth. So my experience for the last 49 years in science helped me to really navigate this new role, which I'll just tell you what it is. Okay, so this I just thought I'll take a minute of where I come from. I did MSc in 72, which makes it 52 year of experience. Joined BARC and then went to Kalpakam, and I was there for almost 14 years. And in between, I got my PhD from ISC and went to postdoc in Stuttgart, came back, moved to ISC Bangalore because I wanted to teach. That is a great passion for me, and set up the lab from scratch using Raman spectroscopy, ultra fast spectroscopy, and vigorously rather on soft matter. That's where Ashutosh and I overlap in our interests. So for youngster who don't know much of soft science, can Google it. What is soft matter? This is matter where you really talk at a larger length scales like colloids, polymers, biomembranes. All those are clubbed under soft matter, and how they flow is a big subject in itself, connecting from the chemical engineering to chemistry to physics or material science. And more recently my interest has been in active matter, which mimics life. And still more recently, is stochastic thermodynamics, which you all know. Now what is stochastic, I'll tell you. What it means in one or two words is, thermodynamics, you deal with bulk system, 10 to the power 23 atoms per cc, right? Avogadro number. Here, when your number reduced to few, 2, 3, 5 particles, can you still talk of thermodynamics? Answer is no. You can, because the fluctuations in the mean of those pressure, temperature, they will be so huge comparable to the mean. So you talk of fluctuating quantities. So the whole subject has now come up called stochastic thermodynamics in the last 10 to 15 years. And it has very, very fascinating outcomes, which I'll tell you one aspect of it. So stochastic thermodynamics is what we have been dealing with. So I'll tell you only one problem. The limitation of time and your patience tells me that I should not go overboard on encashing all the goodwill of Ashutosh. I'll take 25 minutes on this and maybe 20 minutes on the second part, how they connected. So I'll take one example of a heat engine, which many of you read in BSc. Now this, you know what is the meaning of heat engine. You have a piston and a cylinder. You connect it to the heat bath, and you have a cyclic hot and cold gas temperature varying, and you get the useful work. This is the paradigm of heat engines for the last 285 years, since Carnot time. It has not changed. Now in that, there is a very fundamental, there is a understanding which I want to pose, and it is almost thought that is a theorem, but there is no such theorem. This is and I'll tell you only one problem out of that. So what is a heat engine? This is the Carnot cycle, where you plot pressure and volume of the gas. So when you have gas, you compress it in the cylinder at a high temperature. That is called isothermal compression. At low temperature, you heat it. This is the adiabatic heating. At high temperature, the piston comes out. That's the time you connect a flywheel. All your modern day gadgets are linked to that. So in this part, you get a useful work done, and you repeat this at some cycle. So that's when you have to define what is the speed of my engine. Because when you talk of a car, you will have to define what is the speed of my engine. Now this was done by Carnot in 1824. He died very young. You can see he died very young. 1824, he gave this based on his work, the laws of thermodynamics were later made, 8 years later. So it's a very different situation of when we say linear innovation. The fundamental laws of thermodynamics did not come before, and scientists said, oh, I know first and second law, now I'll make a heat engine. That's how we think. It came much before that, and based on that success, actually first and second law of thermodynamics were formulated. So it's a very interesting example of a reverse innovation cycle. So this is what I told you, and you can get the efficiency which is high school material, 1 minus T cold, bath, T hot, and this is true only in the reversible case, which means the engine is extremely slow, extremely slow. Only then you can get Carnot efficiency. I am sure some of you would have heard this word. The more simpler engine is called the Stirling heat engine, which is similar but little simpler. Here you have a isothermal expansion at a high temperature where you get the useful work. Then at this point, when the piston has come out fully, you cool the gas. It's called isochoric cooling, same volume, don't change the volume. Then you have isothermal compression. In this, you don't get the useful work, and then you have isochoric heating. But the net result is that if you do it at a certain speed, you get the work done. And all your modern life depends on this engine. And this gets slightly modified from Carnot because this is not the adiabatic thing, and this is related to volume and all. I don't want you to worry about it. This is a macroscopic limit where the working substance is a gas, 10 raised to power 23 atoms per cc, bulk gas. Now, there is a concept of a nano heat engine which was said. So people started asking when this nanoscience was coming up, can you make a heat engine at a nano scale? Which means instead of big gas piston, you can work with one atom or one colloidal particle. Can you do it? Conceptually, it was completely a breakthrough. Nobody thought it could be possible. So there was a theoretical paper which said it is possible, and he gave a construct. So what they said was that you have to remember it is not just miniaturizing the heat engine, not the piston cylinder, but when you have only one particle in a heat engine, the fluctuations in all this pressure, temperature, they will be huge because there is nothing thermodynamics about it. But that's how the stochastic thermodynamics came, entropy, all those concepts were developed, and they said it is possible if you do the following. And the experiment is very interesting, theoretical experiment. You trap a particle not mechanically but in a laser field. It's called an optical tweezer, and that laser intensity decides whether it is very tightly held or whether it is loose. So this is expansion and contraction, expansion, contraction, and whole thing is in a temperature bath. So the bath temperature can be high, low, high, low. So experiment is very simple in concept, and this was translated, a theory was given in actual practice from a Stuttgart group in 2012 or something, where they made this heat engine after 5 years of work. The reason I know 5 years, I'll tell you, it's an anecdote. I met this person, Professor Clemens, and we had published many years later a heat engine made out of bacterial bath, which came in Nature Physics, and he was very happy because he must have been the reviewer. So he said, how many years your student took to make this bacterial heat engine? I said, maybe 3. He said, oh, you are so lucky. This student took more than 5, and after that he left physics. Because he thought if physics is doing 5 years, one experiment, it can't be his life. So it's a tough experiment, but anyway, it can be done. So they made a heat engine, showed how the work can be calculated from those equations, and how the power and all that. This is what I'll come back in a minute to you. And then the Carnot engine was made very recently. Now, what is the equation? I don't want you to read at all. What you have is the particle in a well. Particle moves, right, at a given temperature. That you measure, that's all. The position of the particle as a function of time. Don't do anything else. Put a camera, digitize it. If you do that, then you know particle position, you know velocity. Using that, you can simply do high school physics. What is the work done? What is the heat? And you can just put that in. And what else you need to know? How stiff is the potential? What is the force constant, right? Spring. You know that quantitatively. Put that, because you have to change K when you are expanding or contracting. So this you also know completely mathematically and whatever experiment, all that you put and you can calculate these quantities and a function of every cycle. And lo and behold, it does work. You can show that it is a finite work, and that work also follows, it so happens, macroscopic equations even though with one particle, which was a big surprise. In stochastic thermodynamics they did that. Now this is the 284-year-old puzzle I want to talk to you. Now there is a cycle time. I told you Carnot efficiency is only possible when it is done extremely slowly. So you plot the cycle time, and this is the time when you will get the maximum work done, correct? Because everything is reversible, everything gets work done. But as you make it faster, means smaller cycle time, it decreases, and below that it's not even a heat engine, it becomes a refrigerator. And efficiency, which is work done divided by what? Heat, is the efficiency, which is also maximum at the largest time. But there is a big price to pay. What is that price? That price is power. You don't need work, you need power, because that's how you need to make your life worth it. That time power will be zero, because power is work by time. Time is infinite, power will be zero. Though you have the maximum efficiency, you have the maximum work done, but it is a useless thing because the power is zero. So what human beings have done, they have found out there is an optimal time, because here it is power is zero, here it is zero, in between has to be maximum. Simple law. That time all the engines in the world work at this cycle time. So for a given engine there will be an optimum speed. At that time the efficiency will not be the Carnot efficiency, but it will be slightly less. So this is what I call power efficiency trade-off. You get finite maximum power, but you trade off the efficiency. So this is the paradigm for the last 285 years, and it was thought that you can never, looking at it, we said what should we do to overcome this 285-year-old paradigm, because we went through the literature right from history of the science. There is no, we don't have to sacrifice, right? That is the one. Now the minimum time is already decided. What is the, now how do you know it is the infinite time? You look at all the processes in your engine. Time larger than that is the quasi-static, right? It's the infinite time. But how can we reduce this so that we still get the efficiency? Which means we have to reduce the cycle time. Can we reduce it? Question. Now this is something which has not been answered. So what happened when we were worrying about it, there are 5 theoretical constructs which have been published on overcoming this paradigm. All these 4 of them are completely theoretical. They write the Hamiltonian, they write everything, and they said if you do this, maybe it is possible, but it is not possible to translate into experiment. This paper, when we were worrying about it, we thought it has something. It is again on quantum system, making a heat engine out of a quantum system, not classical system. But it had a very deep line thinking. It said if you can bring system bath interaction, which means your engine and the reservoir, which is the gas, hot temperature, if you can bring this coupling, right now they are independent. At a finite temperature it works, there is nothing, no coupling. If you can bring this coupling, they showed for quantum system it is possible. So we took that line alone and we said let's see how can we translate into action for a classical heat. Ours is classical heat engine. And this is how this paper came out few years, 2 years back, 1.5 years back. So what we want to now do, bring this interaction. How do we bring? Please look at what is our heat engine. Our heat engine is, this is the heat engine because this is the potential well. This potential well means some spring constant, right? expansion, contraction. If that and the temperature of the bath can be not independent but connected to each other, we can get engine reservoir interaction. That's the point. If you can take this message, I think the talk is over. This is what we wanted to implement. Now, how do we do? In the experiments we had done and the German group had done, the temperature of the bath was a big volume which is heated or cooled by a heater. Now that you cannot control. So we wanted another way to have an effective temperature, not like this physical heater and switching on and off. So this is where we came in with a very nice thing which is very interesting. You take this particle which is trapped, put two plates, copper plates, and apply voltage, electric voltage, random, with some zero mean, with some statistics, and control the magnitude of this, whether you apply 1 volt, 2 volt, all that. If you do that, and then you can show very easily, the effective temperature felt by this will be much higher, and it will depend on the magnitude of this voltage. That's the bottom line. Outside bath temperature is still 295 Kelvin, but the temperature felt by this is controlled by electrical noise. So electrical noise is now a control to do the temperature, and now we said, can this temperature, this effective temperature, depend on the system, which means spring constant K. That's the point. And answer is yes. I will again not go into detail. This is something we can discuss. Answer is yes. If your force constant is below some value, we can prove that. Once you do that, we showed you can make a heat engine where the probability distribution you can show as if it's at a high temperature. All that you can verify. The effective temperature is not 295. You can get any temperature you want. Water will boil at 100 degrees centigrade. But the effective temperature of this can be as high as 1500 degrees centigrade. This is just by electrical voltage. But what we showed, I will again not go into, this is the key figure. For the fixed electrical noise, depending on what is your K, the effective temperature changes. Which means it can vary from 470 to almost 1000 depending on K. This is the most unexpected result. If you are at a very high K, nothing happens, which people knew for 20 years. But at low K, which was not explored because this concept was not there, we showed that T and K are coupled. And this coupling can be destroyed by putting some salt, particle, all that test we did. Don't worry about it. Bottom line is engine and reservoir can be coupled, and there is a definite relationship. Now I'll give you the main result. This was the Stirling cycle when the cycle time is 50 seconds, very large, nothing is surprise. You get all theoretical computed experiment. This is the final result. I just want to take a minute. Look at the work done. This is the limit predicted by theory, and it agrees. It comes down as expected, but now at this time something starts happening. So this should have gone down. It didn't go down because of this coupling, which again I will not explain in detail. This is something was totally unexpected. At the shortest time, few milliseconds, it is very high. And if you look at efficiency, again starts coming down, but below this, which has a physical meaning, which I didn't explain, this again goes up, and this meets the Carnot value. So at low tau, you start happening something new physics coming in, which overcomes this thing. So this is the snapshot. Power is of course very low at large tau, which is expected. Now here it starts coming down. This is the one which is optimal, people know. But in this heat engine, it goes up. and you can see huge change, almost a factor of 100. So what is happening is, and the efficiency again reaches the Carnot efficiency. So what is happening is, you can make heat engine extremely fast, still get the work done, and still get the Carnot efficiency. And this is what we said, you can overcome the paradigm, overcome this huge mental block which was there. Now why it happens, again I will have to seek your forgiveness. What we have shown is, actually with this electric noise, you can get faster equilibration. If this noise was not there, it would have taken 270 milliseconds. But because of tinkering with this noise, it only takes 12 milliseconds. So we played with the relaxation time. That's the major point. And this we could explain, and the physics is that when you have a potential and you apply a voltage plus minus, particle will move towards positive side. Earlier it was all doing diffusion, random. Now we give it a directed motion. That directed motion helps it to equilibrate. It kicks it. Come on, get to the equilibrium, and does that. And this was the major point. And this is where we asked, if this is the physics, can we have another system where can bring the directed equilibration and still overcome this efficiency power trade-off? Can it be? And we showed recently, this is the Rajesh work with student Niloy, that instead of water, we put a gel like a soap solution, and that soap solution behaves like a solid at smaller time, like a liquid at larger time, which you know there are many examples that if you have some gels, I don't know if you are worried about the shampoos, you try to put in a different way, depending on how you rub it, the viscosity will change. So that's how we did that. It is a gel solution, and we wanted to know, when we go to larger frequency of this gel, actually it starts becoming like a solid. What happens when it is becoming like a solid? When it becomes like a solid, the medium, it will have elasticity. So elasticity will ask it to come back, not a diffusive motion. And this is exactly what we showed, and I will not go into detail. This is another way to control temperature using lasers. Let me not give you the details. We made a heat engine and we showed that work done does not come down, actually it again goes up at smaller time. So we can again have this paradigm broken. So the temperature here is varied in a very, very nice manner. This is Rajesh's discovery. Instead of electric noise, you put another laser which can kick in, and controlling the second laser can get any temperature you want with any statistics. So this is what I call the photon phantom, which we used to make this temperature, and we can show that it overcomes this. So let me not go into the detail. Just to summarize this part before I come to Vigyan Bhavan. What's the time? Because time, right? Time is right. Okay. So I thought I'll just summarize this first part. Engine bath interaction, I told you, this is the key part which can overcome this trade-off. Reservoir engineering via the photon phantom allows another tuning of reservoir, and so on. Now, biggest question here is, how do you get useful work for getting something out of it? This is a heat engine, we know, but people always ask me, can you connect a flywheel? How do I know it's going to do work for a real life situation? So this will be a nano thing which we'll have to do, and this is the work which is going on right now, and we have shown that you can connect some cargo and it can drive the cargo. So that is the work which I will not talk about. So these are some other things related to what I said. We used bacterial heat bath, We use coupled. Now, can you couple these heat engines? Like in a, you say 4-stroke, can you make 4 heat engines? Can you couple them? And we showed when you couple them, you don't get 1 plus 1. Actually, you get 1 plus 1 is equal to 4. Much more work and much more efficiency. Again, for a very exciting reason of non-equilibrium statistics. Okay, second part now. And this is something I moved to Delhi on April 25th, 2022. And again, I have to thank Dreamscape AI tool for these things. So what I did, I said a scientist moves from lab to science policy, Vigyan Bhawan, what will it do? And I don't think it is so bad. This is not the AI picture. This is the AI picture. And this is the AI picture. So it also tells the youngsters the power of AI. You have to use it correctly. I use this for amusement, but you use for better purposes. And don't write papers using AI. Because now we have a tool which can detect AI generated turn it in for plagiarism. Now there are many tools. If you can give it, it will tell you whether it is machine generated or human beings. So let me out. So this is something I thought I'll mention what this office is all about. So before me was Dr. Vijay Raghavan. He served for 4 years. And before me was Dr. R. Chidambaram, whose photo I'll show just now, who passed away 3 days back. He was the second principal scientific advisor, and the first one was Dr. Kalam. He served for 2 years. So I am the fourth one. But so the roles of Office of PSA has evolved over a period of time, and in the last few years, this is an instrument of science advice shaping policy choices. Now, we have 2 instruments in our office which we use all the time. One is a Prime Minister's Science, Technology and Innovation Advisory Council, where we have 6 members plus many secretaries who are members, who are invitees. And the other one is again a very important aspect called Empowered Technology Group. So all the technologies which are being bought in government sector, including strategic sector, or before they go to cabinet, they come to our office for knowing it is the latest technology or is it an old technology which is being siphoned off to India and so on. So we do our due diligence with experts, and this is what this does. I'll tell you a little bit of this today, what this has done, and this is related to again formulating the right missions at the right time to know what India should be doing as a whole, and what are the instruments needed for that. So that's what I thought in next 20 minutes I'll tell you. So here there are many technologies which are needed for any nation, and this is not a complete slide. I just indicated few of them: quantum technologies, advanced communication technologies, 5G, 6G, Open RAN, digital transformation where India has taken a lead, AI, cyber security related, biomanufacturing, biosecurity, One Health, clean energy technologies, completely essential, and advanced space technologies, and many more. And the policy cell in INSA is now, which has come up, again can play a very decisive role in contributing to this policy domain. Now, in this PM strike in the last 5 years, many missions have come out which have been launched. So the way it works is PM strike debates on the need for a mission. If there is a consensus that there is enough merit in this, then the right ministry is helped to make a cabinet note, because you need resources, you need funds, and funds can only be given to a ministry, not to our office. That's a good news, because we don't deal with the implementation. We only come in the space where the policy is to be made and empowering mechanisms have to be put in place. Once you do that, many missions have come out. Deep Ocean Mission run by Ministry of Earth Sciences, Natural Language Translation Mission, MIGHTY, AI is now a few months back, MIGHTY has rolled out. Waste to Wealth, our office was running another mission, National Electric Mobility Mission, Green Hydrogen Mission again came out of discussions in the PM strike, and more recently National Research Foundation, another mechanism to support science and technology has come up. Again, it has a history. It came in PM strike and then subsequently it was discussed. So more recent missions in this is the quantum mission, and One Health mission, I'll just say a word or two, and one in the pipeline is National Livelihood Mission, which means how the livelihood of people in villages can be influenced in a positive way by technology. That's the mission. And so let me just say One Health, for example. Many of you may be wondering what One Health is. Now One Health is what you dealt with in COVID. COVID told us that human health, animal health and environment are not separate. They are interconnected because it transfers from there. Which means that if you want a holistic answer, you have to deal with all three. And that is the meaning of One Health. And this 11 ministries are involved and state departments. So it's a Herculean task to bring all of them together, because all of them are doing something or the other on One Health. It's not that it is a new subject, but we want to tell what are the gaps in this connection, and that is all that is a part of this. So it is having an integrated disease surveillance, strengthening routine prevention program, joint outbreak response and pandemic preparedness for future if it happens. So already this has been rolled out, it has been approved by the cabinet, and ICMR is the leading agency. Now first thing which we have done in the last few months, just to get you a sense, we have 25 BSL-3 and BSL-4 labs. BSL-4 are only 2 right now, others are coming under construction. But each department had their BSL labs. So under this mission, all these labs will work together, and depending on the nearness, which is BSL lab closer by, they will have access. So this has been done. Second, another mock exercise was done called some Hindi name, a nice name is there, which was a mock drill for a pandemic. Supposing if it breaks out, what will you do? Are we prepared? So that we did about few months back, and from there we learned where the gaps are. So all this is now going on. So our office led it, and now still involved in a very major way. So many technologies are needed which are being done. National Quantum Mission, obviously all of you must have heard, already rolled out, and all these 4 are the components. But some of those who may not be up on it, I'll just make one slide presented to you. Why do we need quantum? Do people know here why do you need quantum technologies? You have classical computers, right, in your lab phone. Why do we need quantum computers? So I'll just give you one so that you get shaken up and vouch for it. Because all your transactions are based on some security protocol. That security protocol is, for example, it is 128-bit AES, asymmetric block cipher based. All your transaction on WhatsApp and all, when you see a message, it is encrypted, it will say. It will also say it is 128 or 256. This, what is this actually? It is based on factorization of a number. So a very large number cannot be factorized so easily. 21 you can factor, right? 3 into 7, anyone can factor. But if it is a large number, it will take, for example, age of the universe to factor it. You cannot factor if it is a 2048-bit RSA, which means you are safe. But not now. Now if you have a quantum computer with 4000 qubits and 1000 million gates, we are not closer to it, but we are proceeding towards that. This will happen, there is a prediction by 2030. This impossible encryption will be broken up in just 10 seconds. So all your financial transactions will be compromised. All your health data will be compromised. So it's a huge, huge challenge for every country to safeguard it. So what people are doing, our adversaries, they are storing our information and they will analyze later when quantum computers come. Store now, harvest later. That's the point. Or harvest now or do later. This is already happening actually. It's not a science fiction anymore. So all the countries are going on quantum computing mission. India has also launched a quantum computing, and it is so fundamentally strategic importance that I don't know if you have read 2 months back, US has put a complete ban on all technologies related to quantum computing. You cannot buy even a chip. Even a single photon detector you cannot buy which is used in quantum computers now. So it's a big, big challenge for our country or any other country to be self-sufficient in quantum technologies, and that's how the mission has come. So it is going on. A mission has been launched, and many things you can see the Google on Google, a lot of description is there, you can go. Last part on this, I'll tell you about ANRF. This is the National Research Foundation, Anusandhan National Research Foundation. It is another mechanism of synergizing the R&D in the entire country without touching the existing funding mechanisms. DST, DBT, CSIR, DRDO, agriculture, they all have their funding mechanisms. They will continue. This is over and above that, but with a broad umbrella of many more responsibilities. And Honorable Prime Minister chairs the governing board, and the Executive Council is chaired by PSA. And there it has all the goals which you can read, which is not very surprising, that we want to put in more resources and more structure and more ease of doing things, so that this S&T ecosystem along with innovation can be strengthened. So here the industries also are included, startups are included, and so on. So this is the new experiment which has been started. So this is the, if you look at the ecosystem of India, you have all the science ministries. All of them have their science programs, engineering programs. ANRF is coming over and above that, and it will connect to, there is another, I don't know how many of you are following, a new incentive has been announced by the government. 1 lakh crore corpus has been created for R&D in private sector. This will be rolled out anytime because the work is in progress to see the structure of it. It will go to cabinet soon. And this is, all these things together will be really supporting the research and technology and innovation. And this is over and above all the mission programs which are going on. So there is no dilution of any of the programs, which people get often confused, and this is over and above that. So I thought I should mention it. This already, these are the goals. Some of it has been launched already. Just to give you one feel, as of last week, there is a program called PAIR. Have you heard of PAIR? So PAIR is partnering top research institutes with institutes who are not doing so well in research in let's say universities and other departments, and this pairing will be a joint funding where 70% of the funding will go to the spokes which are in tier 2 and tier 3, and only 30% will go to tier 1 on contemporary themes. So this has been rolled out. It has a huge game changing once we put in place. So I will not go into detail. So at this stage, I have 10 minutes, Ashutosh? Okay. So at this stage, I just thought I'll also give you two examples of what our office does. It's not only we tell others do and we sit at home nicely. So we also are trying to add to the ecosystem how we can synergize. So I'll tell you only two programs out of many. One is called RUTA, which is a Rural Technology Application Group, and another is called Manthan. These two will have some connection to some of you here. So I thought you may like to know some of it. So what is RUTA? Oh, first I am telling Manthan, sorry. So Manthan is, I don't know, can I have a very loose language to speak? Not in this, somewhat.
No, no, absolutely.
Only loose language. Only. So this is equivalent of shadi.com. That's the analogy. Which means you have demand side who needs bride and bridegroom, this thing. There is a supply side, they have this thing. So demand and supply we want to match, which is exactly what funding agencies do, because they have certain objectives, they give funds for objectives to be achieved. So so demand side will be industries, they will have some problem to be solved, they have some technical problems. It will be international partners like Bill Gates, Melinda Foundation. They have given central line ministries. So many line ministries have technical problems and they do not know which university to go to solve it. Supply side, we will have educational institutes, R&D labs, all CSIR, DAE labs, startups, we will have incubators, all those things are there. How do we match them now? So there is a platform which is completely transparent and very, very safe, where people can load exactly what they want, and we have the supply side where we have listed the capabilities of each one, and there the handshake is done electronically, not by us, and there they do the matching. And good news is this was launched about 3 years back on 22nd August 2022 after I joined. So this already has done 780 opportunities shaken hands, which means 1321 crore rupees have crossed hands already, and 8,000 crore is our expectation, which are in the pipeline. So what I want to show you is there is so much of demand of solving so much of demand where people want to solve technical problems, S&T problem, and many of them are philanthropic organizations. We have enormous CSR money in the country, enormous CSR money. All these people would like to contribute to research. So what they do, they will probably buy an ambulance, which is a good thing, and do it. Now we are saying you can also do for R&D, which will influence the society in a good way. And that's what is also happening. Many international organizations have come and 16 Center of Excellence have been established. For example, one Center of Excellence in Palghat, IIT, looks at waste, human waste, and our all the waste to energy. That is funded by, I think, Bill Gates Foundation, almost 35 crores, I guess, if I'm not wrong. They are working. So it's not government money alone. Most of it is actually private money. What we have enabled is this platform, and hand holding is done till the end, and make sure that it's a clean money, all that is done carefully. All that is done. 260 academic institutes have been supported, and 916 startups have taken the challenge. So this is really where they are working on a problem which is needed by the industry or the philanthropic organizations. All this is happening. So I thought I'll tell you, these are all our central ministries are participating, global partners are participating, and few industries I have told, there are large number, and this is what is happening. The last few minutes I want to say, because it is started by Dr. Chidambaram when he was the PSA. So I want to really give my salutations to him because he played a very, very major role in Indian science ecosystem for almost like 60 years. And you know that one of the thing which he started was Rural Technology Action Group in our office. So what he did was, he identified 6 IITs and said, you go to the villages and find out what are their problems. And for those problems, find a technology-based solutions. And these solutions have to be implemented on ground and demonstrated and implemented. So this was done actually in the last few years. This was the phase 1. And this is where almost 62 technologies came out, 62. 34 of them we have made YouTubes. You can again go to YouTube, put RootArg, you will get 34 technologies which give 1 minute video because that is your attention span. In 1 minute you will know what technology it is and you can go to the right person. It has a contact address. This one deals with textile, water resource, agriculture, food processing, handicraft, rural entrepreneurship, livestock and others. All these are the places where these technologies have been deployed all over the year. What we found when I started reviewing it, this is extremely good, but it is not really being done at a scale. We just don't need 10 villages. We need thousands of villages where this can go. So how do we do it? Oh, sorry, I don't want you to read. Many technologies have come up. You can see on the phase 2 now has come up. In phase 2, we have gone beyond IITs now, and there are now 8 institutes which have posed the problems needed by the villagers. And it has been vetted, all those has been done, and they have started again on this. This is the last part of my talk. What we found, even when we are doing this, it will have still problems. Why? Look at the statistics. The technology penetration in rural India is only 2%. Only 2%. This is the report. Which means most of the technologies do not go to rural sector. How do we break this jinx is the question. So this is where we have large innovations. That's not the dearth of innovations. But they do not go to the rural area. So what we said was, these are the problems. Can we solve it, or is it an impossible problem? So what we have now done, this is the newest initiative called RootArg Smart Village Centers. What we are going to do, all these 64 technologies which are in phase 1 and whatever comes out in phase 2, they will be positioned in physical centers around the country. There will be a local entrepreneur who will make them by hand holding with the inventor. Oh, this is my, so it says shut up. Yeah, I will just take 2 minutes. Mine. That was mine. What we want to do is these centers, but again, let me give you the fundamental idea behind it. We do not want these centers to be government centric, because once you get government money, you will have tons of restrictions. We want people who want to help us. We want people who want to devote their time and energy and resources, who can help the villagers or the laborer. So these centers will not only be doing the RootArg developed technologies, but any technology which is suitable for villages. So this is what the goal is. A role to be played within the framework based on the specialization of innovator role. This will be the innovator role, and this will be the NGO's role. So we have, everything is on the web, by the way. Everything is transparent, and everyone who wants to make this center can apply with filling the particular thing, and if they cross a threshold they will be asked to be associated with us. It's not that anyone, because we don't want just loose players, we want very serious players. And good news is, so now we are going much beyond root-arc technologies. Villagers need much more help than just the technologies. So we are going to do agriculture services, root-arc is one of them, livelihood entrepreneurship and renewable energy, how we can help in edtech education for their children and them, affordable housing, wash, fintech, R&D intervention, government schemes, lot of government schemes, but they don't know how to even use them. They need, they will be assistive technologies and any other solution which villagers will need as we go along. These are the 12 verticals in which this RSVC will work. Good news is in last 3 months alone, this is only 3-month-old idea. In 3 months, we have rolled out now 22 such centers. All 22 centers are funded for the initial cost by some philanthropy or some state government, and then there is a running one, and the person who are running can be the village Didi, or it can be a panchayat, or it can be young people who want to help the villagers. All 22 are functional now, and all 22 have rolled out agriculture services already. So what are agriculture services? Soil organic carbon mapping, they can do much cheaper. So this technology has been given to them. It's not that they think. Then we have given satellite-based soil nutrient analysis, helping with ISRO. Crop rotation, dose, satellite-based crop monitoring. All these things are rolled out, and we have put a very limited cost on each one. You want soil testing? Don't run to the city. It's just in 40-50 rupees it can be done at home in your place. These are the kits. All that we want to make each center economically independent in next 3 years. We don't want them to depend on us. So this is the model which is working. These are some of the things already working so these are 2 rooms, 20 by 20 feet, 2 rooms, where this root-arc technologies will be displayed. Farmers can come and see what is good for them, and all these things have been rolled out, and many more are now coming in. And good news is that there are so many people who want to help and join us. It's not that there is a dearth of people in the country. So many people want to help with technologies. It's amazing. Actually, if you just get to know this, it's so overwhelming that so much support is there to contribute to society from the technology side. So these are the young girls from the village who are the volunteers. No volunteers, they are actually also paid for such. But all these things are actual pictures. And like, for example, Market Mirchi, a digital platform for farmers by Bombay. It was done in root-arc. Under the root-arc, it has been rolled out, and this is heavily used because you can get the right pricing for your produce. So they don't have to go to the city. So all this, I thought, connects to Vigyan Bhawan. So I told you 2 parts to my life. Vigyan, which I gave you one example of a heat engine paradigm. Other, I thought, equally exciting for me, because whatever we learn in science is actually the rational thinking. It's just that you have to just do rationally. You have to see what will work with the sensitivity of people. You have to be sensitive to what people need and what society needs. You have to do that, and these are again the pictures, again for fun's sake, created using a AI tool. So thank you very much, and God bless you. Want to have?
What is exactly the role of PSA office in that matchmaking?
So our office has developed this platform, And it is not just matchmaking. So we connect to them. Actually, a lot of people just don't come on the platform. Actually, it's not as simple as I made it to be. We have a whole team of people because they don't know what it is. So our team interacts with them and says, this is what is possible. This is there in IIT X. This is what it can connect. And then we meet them. But in financial, this thing, we don't come. We will not say you charge X or Y rupees. No. Depending, and also this is done not as a commercial scale. Everyone wants to kind of join this effort to help. So this philanthropic organizations, CSR money, state governments, all these people have problem statements. And these problem statements are sitting on their desk. It's not that we are the one to create them. And they are now being taken up by these inventors from IIT, most of them, but now the tier 2 cities have started coming in. And startups in small towns are actually taking up this. Because for them, 50 lakhs may be a big amount. You know, it's not a small amount. IIT, it's a small amount. But for others, it's a big amount. And this is happening already. I told you, almost 1400 crores have exchanged hands, done, and projects are closed almost. So we are now having a third party evaluation of what has come out and so on. So we would like to learn from that. It's not that we know everything, and this is something.
Questions?
Yeah.
Professor Sood, what is the precision of the soil testing, what you have mentioned?
I won't know the details.
Because
I can connect you.
Being an agriculture scientist.
I know. I will not know. But if you write to me, I can connect to the people who have given the technology, and I will not know.
Okay, thank you.
But this has
Dr.
to serve the
Sood,
purpose. That is what we want.
very nice talk. Of course, the first part was beyond me because I'm not a physics man. I wanted to ask you this slide that you showed of 159 startups have been supported through Manthan. Can you elaborate a little bit more on that?
So this is not 159, actually it's 300 something.
300 something.
Now, the point is what we have done. Actually, it is on the Manthan platform. You can actually connect to it. So the problem statements were taken up by startups, and there are different startups. Some of them are in hardware, some of them are in AI, some of them are in medical field.
Yes.
Some of them, and they have the solutions which is needed by the demand side. So I don't have the numbers, but these are technology related problems, all of them. So our goal is that it should be technology led, so that we can bring our strength to it. So almost 300, and these are the ones which connected. So what happens is you can do both ways. People can load their problems, or supposing if IIT has a certain solution which they have already developed, they can tell these are the technologies we have. Who are the takers? So for example, some problems come to us from state governments. Like, I don't know, in Kashmir, I don't know if anyone is from there, they make this carpets.
Yeah.
Those carpets are made in a very, very labor intensive way.
Yes,
I don't know
yes.
if you have ever been there. So they will take this wool and they will lay by hand across the floor, because they are not woven in a yarn machine. And then they stamp on it, and then they put the threads. It's a very laborious process. That has been now, so in 1 week they'll make maybe one carpet or even more time. So this problem came to us, can we help? So I don't know which IIT has helped, I think maybe IIT, I forgot the name. So they have made now a machine which does that, and now the whole carpet thing can be completed in few days. And based on that, Srinagar government, LG at that time, ordered some X numbers of these machines, which our office gave. And now let's say we have given 12 of them. They will be put in FPOs. There's farmer organizations. If you want 100 of them, we cannot do that. So we are now telling startups to take up this machine, which can be easily made because technology is freely transferred, no charge, because it is funded by PSA office and given. Second example, which is again is on walnut. I don't know how many of you know the process of taking a walnut, the amount of enjoyment you get, inverse of that is the pain in making that walnut. Because it comes from that fruit, you have to remove that because the inside kernel is embedded. And that one, you have to cut it, your hands become black and they actually corrode. So now the Srinagar Agriculture University has completely mechanized that. So they have come to a stage where this walnut will now come out. Now, second problem which we have given them, in market, walnut has 3 categories and the price differs on that. If it is a white giri, it's very expensive. Slightly colored, little more cheaper. And slightly blackish is freely, well, not freely, less this thing. They do by hand now. These women sit and, so what we have now told them, it is AI based technology. So the image analysis will be done, is being actually developed, and based on that, when this is all on a roller, they will go into 3 bins, depending on that AI answer. So that is how our office comes in. So we have told them, you have come up to here, it's not good enough. Now you do this. Once you do that, then up to the, so these are some examples, but there are many.
Very, very nice.
So, Dr. Sood, it's a very glorious journey from Vigyan to Vigyan Bhawan.
Thank you.
I just wanted to know about One Health. This is very, very vital in the present scenario through the mission of PSA. And where do we stand now in terms of surveillance, reconnaissance, response, preparedness, in terms of if such an eventuality occurs?
No, what you have asked is a very, very important question. In surveillance, I don't know, many of you might be involved in that. Environmental surveillance was started in COVID time. But then it has slowly reduced because unless this, what is that new virus, HPMV, but it's the more recent thing, right? So the idea is you don't go to people and test them. You test the sewage, you test the hospital sewage, you test airport air. All that is, environmental surveillance. That has been now strengthened, is going to be strengthened. So we have put SOPs in place. So this mock drill which we did 3 months back, we identified, supposing there is an outbreak in a village, how will you know it has happened? Actually, there is no mechanism now. Right now, people will travel, there was a case here. Word of mouth will go. Not now. So now we have a mechanism which is proposed, and now in the mock drill we showed, we wanted to see how it works. All of these will be put in place. For example, if there is an outbreak, who will go? Ministry of Health, Animal Health, Environmental Zoo. Who will go? Nobody knows. Now, actually, it's an office order. There is a team which is called response team, one from each with name identified. It's not like Joint Secretary X. No. And they have to immediately rush to that place. So all this is needed actually. So that's what many things on vaccine development and so on. It's a big, long journey. We hope. Yeah.
Professor Sood, a short question and a short comment. In nanometric solids, we used a term called entropy catastrophe. When you start reducing the crystallite size below a certain size, the system collapses and crystalline becomes a non-crystalline or amorphous solid. And in fact, many size-dependent properties were explained. So your stochastic thermodynamics rests on somewhat similar, because it's on classical mechanics concept.
No. It is classical, but instead of U plus W is equal to Q, is the second law. Here you will talk of the variance. du plus dw will be dq. So everything is in terms of variances, not in terms of mean. So the three laws of entropy again is having the counterpart. So the idea is that if you work with variances, which is the second moment, you can still talk of thermodynamic laws as first law. This is a new thing. It's not something which was known 20 years back. And still you can talk of these laws of thermodynamics, which were done for average quantities, temperature, pressure, volume, all that.
So is there a threshold, like you need so many particles?
As long as you start getting fluctuations in the parameters, this becomes relevant. Okay. That's the whole.
Thank you. And just a quick comment, something which you mentioned about root arc, I can feed you with a small example, very interesting. Sandeep Sangal of Kanpur took a project, and that was to show how the horseshoe, the way horseshoe is created, we all know it's a forging process, but after the forging, the person would dip it in hot water, dip it in water, bucket full of water. And over a period of time, because the hot object is dipped, the water evaporates, the volume of water decreases, and the poor fellow starts complaining कि अभी से ये काम करना बंद कर दिया. So beyond a certain number of trials, the fellow used to complain that my horseshoe is no longer getting the right kind of hardness and longevity. So Sandeep Sangal showed that instead of water, use a sack full of graphite.
Oh.
So the cooling rate says you get more martensite up to a deeper depth, and it works much better that way. And the fellow was really thrilled. So when he demonstrated this in front of Dr. Chidambaram, he was visiting Kanpur, he was absolutely thrilled.
No, that's why. Actually, there are other things which maybe from IIT Kanpur or something is called sabji ki kathi. Have you heard of this? Sabji ki kathi, you know what it means, right? That radar to sell sabji. That actually the sabji goes bad in 1 or 2 days time, depending on what vegetables you have. So this IIT, I think it's
Kanpur.
Kanpur, I think. No. This is where I want to reserve my comment. Because in a weaker moment, I don't want to give credit where it is not due. Sorry, maybe IIT Kanpur, sorry. So what they did, it's very science-based. If you put an apple in a cart, why will apple go bad? Any students, can you guess? What does it mean? Oxidation of what? Because bacteria start growing on the skin, right? And they will really make the food sweat. So this innovation is without electricity, because you can't make battery and all that heavy thing. So this innovation is they have put a aerosol in that chamber, which I think it's ozone plus something, I don't know what it is. It actually immediately removes whatever bacteria get coated. And that way you can keep for a week. And it is biosafe. So it's not like you're putting a chemical or something. It's not chemical. I think it's ozone. But ozone is produced in situ. So I'm saying it's a very simple idea. You ask scientifically why apple has gone bad. And just analyze that problem and give the solution. What refrigerator does the same thing. It slows down the reaction. That's all. So instead of refrigerator, this was done, and this is in big demand, I told you. Many vendors want, but what our goal is now, reduce the cost of the sabji ki kati. So we are bringing now entrepreneurs from the village to make these things, because fabricators can be made these things. So many examples are there. You can look at the YouTube, 34 of them. Very interesting. Tulsi bead mala. I don't know if you have gone to a temple, they'll give you a tulsi mala. It's very difficult to make because people do by hand, and it takes a few hours and their hand gets hurt. This small instrument actually helps them to make the mala much faster, and many people are using it. So many examples. Actually, it's you will not even think of these problems, but they are really real life problems. Thank you.
So one quick Vigyan question. Something very interesting you said, that a single particle, but over a long time, is producing results for large ensemble of particles.
Exactly.
So is it because for the systems that follow ergodic theorem, and so
Markov process actually.
So time averages would the ensemble averages.
Absolutely right.
But are there examples where that this would break?
Yes, and that is what we showed. If the processes are non-Markovian, which is another way of saying memory, this is what we introduced by this noise. This need not be the case. Precisely.
And then Vigyan Bhawan question. So you have these centers which are showcasing Ruta technology. But they could also showcase many other grassroots technologies which have same problem of scaling up. And one such example is NIF.
Yes.
Right, they scouted a lot of technologies, but same problem.
I said 1,16,000 technologies are sitting actually on the desk.
Yes.
And they are not, answer is yes.
Yeah.
So in RSVC, this will be done. Not in RUTAG, because RUTAG we want to develop.
But the centers, I mean.
100% correct.
Correct.
Actually, that is how this whole concept came up. Because 7 RUTAG centers or 8 RUTAG centers cannot solve whole of India's problem. We need many more.
Yes.
And what you are saying is absolutely right. There are many bodies who have the solutions ready.
Right.
But they have never been
scale up
up.
and connecting is a problem. Right.
So this has been now put as a part of RSVC.
Very good. So there are no further questions?
Can I ask a question?
Oh, there is.
Good afternoon, sir. My question belongs to your study of the Vigyan. As you said, it's a Markovian process. But I would like to say, sir, you are most of the time using the quantum classic mechanics. Like you are using the coherent light to produce this type of phenomena on the single particle. But if you look into a larger this thing, the entropy is always increasing in the coherent this thing. Sir, I would like some time of yours when I can explain you this couple of my concept in this.
Sure.
Secondly, I would like to...
When I go back to ISC, I'll call you.
Thank you, sir. No, sir. Yes, sir. I've been to the ISC a couple of times. Sir, second thing, I would like to know about your engine, meso engines, because I'm trying to design a very small engine, what you are saying, sir.
That's what...
thermal engine.
Do you have access to these journals?
Yes, sir. I have an access. I'm a senior fellow member of IEEE, and I don't know large number of these.
So if you go to my web page, there is a lot of press which has come out on these.
No, sir. I'm asking different questions.
No, I'm saying you can...
How to use it?
That is the $1 million question.
Sir,
can I connect a flywheel? Is that the question?
No, sir. I'm working on a flexible design of a rocket robot like a leech. I think there we have a possibility of using this engine because it will be a very nano scale and I want them to move, like this.
Yeah,
so I may come to you for this. Thank you very much, sir. Thanks.
What happened? Student. Yes. Students cannot be refused. Ask. Can you...
Sir, it's applications of nano heat.
Can you introduce yourself?
Sir, I'm Srinidhi, sir.
From where?
From Amity.
Amity. Which class?
I'm currently pursuing BSc in chemistry second year.
Very good. Tell me.
So you were explaining about nano heat energy like this. So we just need to know about the application and how it will benefit us in like day-to-day life.
Yeah, see the point here is, if you understand how these engines work, then bigger question is, can you take some learning from here and apply to biological motors? You know your body is full of motors. This is a motor, right? That's how you are doing. You are walking, you are doing, even blinking your eyes has the motors. Question now is, if you understand this physics, what are the lessons you can learn for other motors? If there are two motors next by, will they help each other or will they not help each other? So ours is a kind of model systems which helps you to do this. That's the whole idea. Any other question? Yes. He is prompting you or asking you to sit down? Come. Yes.
Sir, it's just like in future, like for masters, if we need to like pursue like for pharmaceutical chemistry, like how are we supposed to like proceed, like the research institutes and everything? We just need like a gist for.
How pharmaceutical?
So like pharmaceutical chemistry, like medicinal chemistry.
Oh yeah. Okay,
Yeah.
I'll give you an unconnected answer, but it might be somewhat closer. See, the point is, how do you discover a drug molecule? That's the question, na? Pharma. Now, drug molecule works on some principles. Either it will attach to something, it will block the motion or block the function, or it will do something, produce some antibodies which will help. Correct? All this has to be understood on a molecular level basis. This is possible up to a limited one using molecular dynamics. People do docking studies. I don't know if some of you are here. People do docking studies. On a computer, they will have a drug molecule, they will have the receptors, they will see which is the right drug molecule which will connect and block the function of that protein. That's how the drugs can be thought of. And that is why it is quite a long process for any new drug discovery. This hope is now, already pharmaceutical companies are investing, do use quantum computers. Whatever classical computers can do in a much bigger way, many more steps quantum computer can do, and that is one very hot area these days.
Thank you, sir.
Thank you, sir, for revitalizing us with your wisdom. Thank you, sir, for revitalizing us with your wisdom and phenomenal persona. It is indeed our pleasure to have you with us today. I now request Professor Ashutosh Sharma to present the token of honor to our esteemed chief guest, Professor Ajay Kumar Sood, for delivering the distinguished lecture on the INSA Foundation Day. Honorable PSA sir, I wish to bring this to your notice that in the morning we have felicitated all our INSA senior fellows. So I take this opportunity and request Professor Sharma to felicitate our INSA fellow as well as our former president INSA.
I thought I was much younger. So now it's a reminder.
I now request Professor Ajay Sood sir to felicitate Professor Ashutosh Sharma, our esteemed president and also elected senior fellow from 2004 batch, which is indeed worth witnessing for all of us as the former president INSA shares the stage with the current president. We extend our heartfelt regards to you, sir, for taking out time from your hectic schedule and marking this spectacular afternoon with your gracious presence. Thank you so much, sir.
No, I have to take my complete.
Okay. This one?
Yeah, it's mine. I have given you that mic.
Yes. As sir is having a tight schedule and prior confirmations, we extend again a warm gesture of thanks to him for gracing the occasion today. Thank you so much, sir. Thank you so much. Thank you. Felicitate the retired staff. Yes. Yeah. Okay. Okay. I request everyone to please get settled. Sir will leave due to his prior commitments, but we are still on with our program. So I request everyone to please settle down. Sorry, sir. I request everyone to please settle down. Ladies and gentlemen, we now take a moment to honor and express our heartfelt gratitude to the senior retired staff of INSA, whose dedication and service has been instrumental in shaping the Academy's legacy. Let us felicitate them with our deepest respect and admiration. I request Professor Ashutosh Sharma, along with Professor Indranil Manna, Professor V.M. Tiwari, Professor Sanjay Puri, and Dr. Brijesh Pandey to please come up on dais and felicitate our retired staff of INSA. We are honored to have with us Shri Satyapal Sharma, okay. Moving ahead, Shri C.P. Agarwal, Shri Satyapal Sharma, I now like to invite Shri Dinesh Chandra, I now invite Shri Ashok Kumar Jain, next we have Shri Jairam Singh, next we have Shri Mahanand, I now invite Shri Samay Pal, I now invite Shri Rajbir Singh, next we have Shri Vikram Singh Rawat, I now invite Mrs. Shabnam Shukla. I now invite Shri L.P. Joshi. I now invite Shri A.K. Kapoor. Shri A.K. Kapoor. Next we have Shri J.M. Gupta. राजवीर सिंह सर नहीं, एक बार पूछिए. राजवीर सिंह. राजवीर सिंह. I now invite Shri S.K. Sani. Shri S.K. Sahani was our former Executive Director of INSA. A big round of applause for you, sir. No, next. अब वो आ रहा है 25 years. Ladies and gentlemen, I now take the opportunity to invite our currently serving INSA staff who have completed 25 years of service for the Academy. The first in line we have Shri K. Jain. I now invite Shri R.K. Malhotra. Next in line, I invite Mrs. Piyu Das. Our currently serving INSA staff whom we are felicitating have completed 25 years of the service to the Academy. A big round of applause for their dedication and hard work for the Academy. I now invite Shri Amit Jain. Next, I invite Mrs. Vandana Gajre. Next in line, I invite Mrs. Varsha Jain. Next in line, I invite Mrs. Purnima Sharma. And last but not the least, I now invite Shri Manoj. Staff members are the backbone of our academy who dedicated their time and energy for the upliftment and upholding the legacy of commitment towards science and administration. A big round of applause for all the staff members who have retired and who are currently serving INSA for now and forever in future. Thank you. Thank you, honorable dignitaries. I now invite Dr. Brajesh Pandey, Executive Director, INSA, to deliver the vote of thanks.
गुड इवनिंग। आज दिन भर के इस कार्यक्रम में आप सभी लोगों की सहभागिता रही। सभी लोगों के प्रयास से ही हम आज ये कार्यक्रम सुचारू रूप से कर सके हैं। आज की इस पावन वेला मैं कह सकता हूँ, इसके ऊपर सुबह यहीं बैठे बैठे 2-3 लाइनें लिखी थी, तो पहले उसको मैं पढ़ना चाहूँगा, उसके बाद आगे बढ़ना है। नवज्ञान की मशाल जलाए, विज्ञान का आलोक फैलाए, 90 वर्षों से ये गाथा, खोज और सफलता की कथा। वैज्ञानिकों के सपनों को दिया आकार, नवाचारियों का किया समुचित सम्मान, प्रतिभा को मंच, ज्ञान को उड़ान, हर शोधकर्ता में किया नव ऊर्जा संचार। संघर्ष से आगे बढ़ते रहे, हर चुनौती से लड़ते रहे। आज 90 साल की ये यात्रा बनी प्रेरणा की नई धारा। भविष्य के सूरज को साथ लाएं, नए आयामों को हम अपनाएं। भारतीय विज्ञान की ये पहचान, रचे इतिहास, बढ़ाए मान, बढ़ाए सम्मान। आइए सब मिलजुल कर विरासत को आगे बढ़ाएं। इसी कामना के साथ आप सभी का इस कार्यक्रम में आने के लिए बहुत बहुत धन्यवाद। इन today's program, it is my privilege to deliver the vote of thanks for concluding and that giving INSA Distinguished Public Lecture Series during the 90 years of celebration. Today, that is my journey from Vigyan to Vigyan Bhawan by Professor A.K. Sood. हम सभी ने उनके विज्ञान और विज्ञान के जो विज्ञान भवन तक की जर्नी है उसके बारे में साक्षी रहे। आज कैसे उनका हुआ। See, this program is only possible because of the constant guidance of our president Professor आशुतोष शर्मा। 1 महीना पहले जब मैंने कहा कि कभी इस प्रोग्राम के ऐसा कभी इंसा में नहीं हुआ फाउंडेशन डे, तो इन्होंने बड़े ही बढ़ चढ़ कहा करते हैं और कुछ अलग तरीके से करते हैं। और इसके दिन में इसमें एक पूरे दिन का प्रोग्राम आया। तो सर आपका बहुत बहुत धन्यवाद कि आप हमेशा गाइड करते हैं इस तरह के प्रोग्राम में। और वाइस प्रेसिडेंट प्रोफेसर इंद्रिल मन्ना, प्रोफेसर संजय पुरी, प्रोफेसर तिवारी, आप सभी का बहुत बहुत धन्यवाद कि आप लोगों ने इस कार्यक्रम को करने के लिए अनुमति दी और साथ दिन भर रहे। आज इस कार्यक्रम में हमारे बहुत सारे ऐसे इंसा के स्टाफ हैं जिन्होंने पिछले 3-4 दिनों से रात दिन एक करके इस कार्यक्रम को सफल बनाने का काम किया। और सही कहें, जैसे सर प्रेसिडेंट सर कह रहे थे कि 1 सप्ताह में पूरे कार्यक्रम की तैयारी की गई है। सो आई स्टार्ट विथ डॉक्टर किणकिनी दास गुप्ता. Even she is not well, but she has constantly watching and monitoring this program. Sri Sunil Jokarka ji, Madhavendra Narayan, Kartikeyan, R.K. Malhotra ji, Shruti, Aditya, Richa, Nidhi, Anu, Tripti, Shaili, Atri, Ananya Banerjee, you have already seen since morning. Famida, Tarika and Monisha, all these people have put their 100% effort to make this program successful. I also thanks W. Selva Murthy ji for their constant support and coming here and with all the MIT staff. Sometime, sir, your presence will also give us lot of energy that yes, we can organize this kind of program, and we have people like you to come and support us. So thank you all of you, and we will continue this INSA Distinguished Public Lecture Series in future, and we need your support in this particular program. Thank you so much.
I request everyone to kindly stand up for the national anthem.
Janaganamana Adhinaya Janaganamana Adhinayaka Jaya He Bharat Bhagya Vidhata Punjab Sindh Gujarat Maratha Dravida Utkala Vanga Vindhya Himachala Yamuna Ganga Uchchala Jaladhi Taranga तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
I request all the attendees to please join us for the tea session and refreshments. Thank you. I request everyone to please gather in front of the auditorium for the group photograph as well. Thank you.